So now we get to look at lesson 4, where we finally get to divide functions. But first we have to do some interpreting of our graphs. So we've got f at x, which is the parabola, and we've got g at x, which is the line. And we're going to have to do some interpreting of the points. You can see that the first point has been done. When x equals 4, the f at x graph is up at 14 and the g at x graph is up at 2. I'm going to do a little bit of reading and record some points, and then you can check my work out. So reading the graphs is fun. You've got to go through the parabola. So find the x value, for example, of 2. And we can see that when x is 2, both the parabola and the line are at 0. Then go to x equals 0. When x equals 0, the parabola is sitting down at -6 and the line is sitting down at -2. So we've translated our graph into a table of values, and now we get to do some division. Again, I'll write out a couple, and then we'll figure out what that division should look like. So 6 divide by 1, 0 divide by 0, that's probably going to be bad. -4 divide by -1. And I'll do some work. I'll pause the recording. We can check it out in a minute. So check out the divisions. 6 divided by 1 is 6. Make that look a little nicer there. 6 divided by 1 is 6. 0 divided by 0 gives me a problem that's undefined. -4 divided by -1, and then moving through the rest of the divisions. -6 divided by -3 is 2. -4 divided by -4 is 1. All the way down to the bottom. Now we've got some issues with division, and that comes up quite quickly here. The domain of the function is not x as an element of the reals, because you can't divide by 0. No division by 0. So x cannot be the value that caused that undefined state. X cannot be 2. So we could build the graph and show a circle at that spot where X, an open circle. You could build that graph if you like. And I'll do that right away here. I'll do the algebra down here and then come back and build the graph. So algebraically, we were taking the parabola x squared plus x minus 6 and dividing by x minus 2. For those of you who recognize the factoring possibilities here, that factors into x plus 3, x minus 2, and x minus 2 in the denominator. That gives me a clear restriction on what x cannot be. X cannot be 2, but x is still an element of the reals. And y has to be written a little bit funny. We've got a gap in that circle, so we'll worry about the range restrictions a little bit later. Evaluating f at g, f divided by g at minus 6. It's nice if I can just use the simplified result. The simplified result being x plus 3. This actually simplifies into x plus 3. Because x minus 2 and x minus 2 cancel. So I can evaluate f divided by g at minus 6 by plugging in minus 6 into the statement and generating a minus 3. I'm going to go back and build that graph. Give me a minute. I've built the graph, and you'll see that green circle in the middle indicating that point of discontinuity. The graph is not continuous. So the green circle is a hole in the graph We'll study this type of graph a little bit more later. It's called a point of discontinuity. Now let's practice all of our skills. Let's turn the page over. So we get to do a little bit of practice with our division statements and focusing on domain. So it's always going to be f over g. So in this case, 2x plus 5 over x plus 5 will be my new function of f over g at x. No canceling is possible, no factoring is possible, but x cannot be equal to -5 because that'll put a 0 in the denominator. So similarly, we'll look at b, where we're building f over g at x. X squared minus 2x minus 35 over x minus 7. Right away you can see x cannot be 7. That's my domain restriction, something we're getting used to. But I can actually factor on the top. I can write that as x minus 7 times x plus 5 over x minus 7, so that this statement actually simplifies into just x plus 5, but still x is not allowed to be equal to 7. We'll slide down to the next equation. So worrying about the same things, taking a look at the numerator and the denominator, a little bit more room to work here. So f over g at x. Try to get your brackets in there to keep things together. 2x squared minus 13x minus 7 over 2x plus 1. And then it looks like the top will factor. I'm going to pause the recording and factor. So I've got my factoring work almost done. I can see from my first statement that 2x plus 1 cannot be 0, which means that x cannot be -1/2. And in the factoring step that I'm at here, I get to collect the x minus 7, which is a common factor. I'm left with 2x plus 1. Divide by 2x plus 1, which is going to allow me to cancel the 2x plus 1, simply resulting in x minus 7. Again, two different ways to evaluate f over g at 3. I can either plug into the single equation, or I can plug into both equations. And then I have to divide. For this occasion, I think I'm going to use the single equation. So f over g at 3 is simply equal to 3 minus 7, which is minus 4. Now we really get to put our work to the test. Can we put all of the ideas together? State the domains individually of f and g. Remember, you're focusing on the denominator, so x cannot be equal to 1, and x cannot be equal to 3. And now I have to play around a little bit. Evaluate 3 at 3 times f times g at 2. I'm going to figure out what f at 2 is, and I'm going to figure out what g at 2 is. And then I'm going to do the operation that's called for. So f at 2 is 2 times 2, which is 4 over 2 minus 1. That's 4 over 2, 4 over 1, pardon me. Simply 4. G at 2 is 2 over 2 minus 3. That's 2 over -1, which is -2. So I've evaluated my functions at 2. Now I have to multiply them together and then multiply that by 3. So I've got to go 3 times my 4 and times my -2. So 4 times -2 is -8, and 3 times -8 is -24. Again, we get to practice what we've learned. Now I have to add the functions f plus g, state the restrictions on x, so that's going to be interesting. I've got to copy those functions down a little bit. So function f is 2x over x minus 1, and then to that I have to add x over x minus 3. Now this is working with fractions. Fractions are most people's least favorite thing. I'm going to have to find a common denominator and do quite a bit of work to make this look beautiful. I'll track my work as I go. Common denominator, easiest way to do that is multiply your 2 denominators together. So x minus 1 times x minus 3. Remember, those domain restrictions are going to play a role with us. This needs x minus 3 on the bottom. I applied on the top. The second fraction needs the x minus 1. I apply it on the bottom, and I apply it on the top. In this case, the denominators don't cancel. It's not an equation, it's an expression. So in the denominator, I'm going to have that FOILed result, x minus 1 and x minus 3. And in the top, I've got to do a little bit of foiling. So 2x squared minus 6x. And to that, I have to add x squared minus 1x, which simplifies on the top to 3x squared minus 7x over that denominator of x minus 1 times x minus 3. And if you wanted to simplify a little bit, see if there's any opportunities for canceling. The only thing that I see as being possible is factoring an x out. So that would be x times 3x minus 7 over x minus 1 times x minus 3. And remember the restrictions that we already said. X cannot be 1 or 3 based on the denominator not being 0. And we had said that already. One last discussion, and that is to divide. So we can multiply, we can add, and we can divide. Now I have to divide f by g, which again is going to involve some work. F is 2x over x minus 1, and I have to divide that by x times x minus 3. We explored this concept in physics yesterday, and that involved multiplying by the reciprocal to simplify fractions. So we're going to multiply by x minus 3 over x and x minus 3 over x. What you do to the bottom, you do to the top. The reason we did it is to remove the denominator, which is awesome. Before I do any foiling in the top, I'm going to do some canceling. So the x here and this x cancel. So I'm going to end up with 2 times x minus 3 divided by x minus 1 in its simplest form. The restrictions on x have to go back to the original. X cannot equal 1, and x cannot equal 0. What else can x not equal?